Tas bija atgādinājums, ka noņemiet skaņu telefonu. Hey guys. So yeah, it's a lot of people here, right? I remember 2012 when Anton invited me into the Oracle conference. That was my first DevOps talk about infrastructure as a code. I've got 3 people, 3 people in my room, and after 10 minutes approximately, 4 more people came, and I thought, oh my God, thank somebody else came. But they just came, took some chairs, and went out. But now it's I'm really impressed, yes, and yeah, to see so many people who love Kubernetes. Right? And yeah, let me start. Today, well, this is quite a fresh talk. I don't know yet timing. We'll see. But it was a long time when I wanted to speak about operators. Well, this is quite a new thing from the maturity perspective. However, the ideas behind these operators were around for several times. Right? I implemented my own operators before this thing was named Kubernetes Operators in some technologies, and I've done my mistakes. And here I am trying to, well, tell you what I actually learned, and sometimes learned in a hard way. Right? So, but speaking about myself, I am working in a small company called Agile Stacks, and we are doing professional Kubernetes. We actually a DevOps company that writes a lot of automation scripts. Automation, well, everything, right? Our dream is automate ourselves out of job, and we have our own approach how to generate automation for primarily for Kubernetes, right? We pretty much merit to this technology, but at the same time I'm doing a lot of development, and I work sometimes as site reliability engineer, sometimes like 4 or 5 days a week. And if there is any opportunity to speak about DevOps, infrastructure as code, and everything which is related, I'm trying to not to miss this opportunity. So, let's start. I want you to meet another one guy. His name is Bob. He will be our hero of today, right? Not me, this guy. So, by the way, this picture and Bob and so on belongs to Lego. I must tell this disclaimer, because I forgot to put it on my last slide. Yeah, but okay. Let's start. Bob is SRE, who is Site Reliability Engineer. And what is he doing? Bob is actually making sure that the website or web service that he is responsible to is working fine. It's online, operational. Well, it sounds familiar, isn't it? Right? This is what system administrators are doing like for several decades. DevOps people are doing like for several years, and why do we need to invent another one acronym for that? But I'll try to answer on this question, and then slowly lead you to the operators. One more disclaimer. Bob, like many of us, loves Kubernetes. Right? Why? Because Bob is doing traditional work, and actually only thing that he cares about, he wants to be happy at work. He wants to do the work that he loves and love the work that he does. And here's what he is doing. So he has some user applications that is, well, today is 2018, so we must package it inside of the containers. right? It's a Docker everywhere. And then Bob has a Kubernetes cluster, and he puts these containers into the Kubernetes cluster. And the first thing that he needs to take care about is the deployment. And deployment is where Kubernetes is really great, in my opinion. Right? By telling deployment, I mean that Kubernetes has a nice declarative API. So basically, everything what Kubernetes has, he provides as the resources. And you can create resource, delete resource, update resource, batch resource, list resource, and most important for us, what will be watch for the changes of this resource, right? And another thing which Bob likes about is that everything through this API he can express as the collection of resources, and put it inside of the YAML files or JSON files. Kubernetes doesn't care, and store it somewhere in the Git. Right? And because this is automation, and he likes to do work which is meaningful, like do it once and then just relax. He doesn't like to do every like monkey job work. Right? So yeah, and all these things he can do to achieve the full automation of his deployment tasks. He can create Kubernetes pods, services, persistent volumes, and so on and so on. Right? Everything he can describe as the code. And yay, he's happy. So let me give you an example. And this example will circle around a little bit. And this is what he is doing. And actually, I have it running somewhere in the cloud. It's actually exactly the same. So I have a continuous integration server. And I just decided to use continuous integration server as the metaphor. But my talk is not limited to CI stuff, right? Instead, I decided to use CI because I was looking at the content of today and thought, oh, yeah, probably CI will be the closest. And then I spent, I don't know, hundreds of engineering hours inside of the Jenkins, specifically. And I know this, and I spent a lot of stuff of doing this very deep integration to the Kubernetes with the Jenkins. Right, so I decided that this thing will be nice for today's talk. But together with Jenkins, so this is his application that currently this blog is concerned about. He has Kubernetes pod, which is a collection of Docker containers with the quantity 1. He has a service to load balance his single Jenkins master pod. Then he has a persistent volume, which is, in this case, it's actually an FS. He has ingress, so because he wants to connect to this Jenkins with his browser. And configuration is expressed also as the code, as the config types. Right? Cool. So basically, he wrote one script, just once, and then he can deploy as many Jenkins as he wants. When the user comes, when the new user is coming, he just said deploy. When user is leaving, he says undeploy. That's it. This kind of work he loves, right? And yeah, by the way, once again, disclaimer: this is not limited to the Jenkins server, right? Not limited to one CI stuff. All right. So, and once again, he's happy. And now it becomes interesting because there is another task. Once his application has been deployed, it must be remain operational, right? And what I do, I previously wrote this vertical line, and this is what I say when I say this vertical deployments. When I say, when I do just a deployment, because I take a pile of Kubernetes resources like and just put them on top of each other. There is not a big variety because pretty much every Jenkins installations looks more or less the same, right? They slightly vary, but not a lot. And this work is kind of static, right? But then becomes user, and here is another axis, and in this journey called operations, it's horizontal operations, right? And when users are coming, they have their own requests. A lot of them. Oh, I want this. I have this strange language which starts with a P, H, something. Can you deploy it? I have this. I have that. I need this. I don't need this. This conflicts with my stuff, and so on. And what happens? Bob is not happy so much. Why? Because things become tricky when you start to do operations. First of all these users, they demand changes every day, new changes. And the reality is that the infrastructure as code is not working with the classical meaning of this word in the Kubernetes. Because in the classical meaning of the word, what's the infrastructure as code? So I write my code, here is a change, I put it inside my code, and I deploy a complete replica of my infrastructure nearby. Then if I'm happy, I'm just switching the users there, right? Cool. This is not what user expects from the Kubernetes. It runs. I have another one container for you to run. Please run it. Right? I don't want you to destroy all cluster whenever I want to run one container and just rebuild another one cluster with my container. No. Just run my container. Here is my special requirements. Just put it inside of your cluster and run it. Right? But that also means that Bob have to do the configuration that typically tended like more traditional to the system administrators, where they have to go to the servers time to time. I'm doing it periodically with physical machines, and time to time applying some custom things there, because I have to. Right? And this is what happens with the Kubernetes as well. Because we cannot just undeploy it. Because if we undeploy it, all our users will just go home. Right? So then that also means that if infrastructure is code basically failing, that means that there is the all automation efforts becomes failing, right? The all automation effort is nice, but only for this initial start, which is this deployment, but not for operations. Because to do operations, you have to do something more custom, something specific. Why? Because requests are coming periodically, and the second thing, the variety of the choices of the request is so big, so you cannot just adapt. You cannot just build code once and just replicate it every time. You have to build the code for every request, which may not be as good, right? And of course, sometimes things become broken. You have to manually go and fix things, yeah. But he still dreams if he can use some infrastructure as code and some automation to do that. Right, and yeah, this is, I couldn't resist. I promised to speak in English, but if you've been in Moscow, there is like they fight with the suicides, right? By putting in the subway, выход есть instead of выхода нет. Right. So there is an exit, and this is where our Bob becomes something that we call in our company SRE, Site Reliability Engineer, but we borrowed this from Google because this is what Google have done for a lot of time, and specifically here is a difference. So instead, Bob, of doing this traditional stuff like infrastructure as code or like shell scripting and so on, he tries to identify, oh, this operation that I have to do periodically. Just how about I will write a program for that? I will not use shell script. I will not use, well, I can use, right? If it's, this is the perfect tool for to solve my task, I will use my shell script. But often it's not, right? Especially for container clusters, right? And so he decided that he will, instead of taking this DSL, like Ansible, instead of shell script and so on, he will use basically general purpose programming language, like JavaScript. Well, JavaScript is not the best one for this, but well, like Go language, right? And he will write something that is called operators. What's the operator? This is a program that is quite small. It's written in with the conventional manner of system engineering, system software engineering, and this program intended to do one thing, one concrete operation, with only one purpose, is actually to solve the operational stuff, to make sure that this Kubernetes cluster, in this case Jenkins, still operational, still working. When users are coming with a new requirement, if what Bob will do, he will understand, okay, this requirement is, I've seen it again, okay, let me write a new operator for that, to tackle this concrete operation, right? And then he will end up with a batch of small, fine-grained utilities that will solve his concrete task, right? And this is what has been called operator, and he becomes more like a software engineer, and because he's basically spent his days not in the Linux console, but in the IDE. Right? So he writes operator, and operator will react by itself on the configuration changes when it's coming, when somebody asks to reconfigure Jenkins. And then what Bob wants to do is actually to write, to declare the new state of the configuration, and then let operator to bring Jenkins into this desired state, right? And at the same time, he will write another operator or group of operators that will listen the cluster events that are happening inside of the Kubernetes cluster, react on it, and maybe adjust the configuration of Kubernetes, or schedule some backup procedures, or maybe something else, right, by itself, because they spotted some pattern inside of the cluster itself, right? And yeah, let's talk about operators. Yeah. So, what's the operator? Operator is the pattern. It was for a while ago, but it was started to popularize during the last couple of years, and well, probably I would give a credit to the core OS guys. Oh no, this company was acquired by Red Hat. So to Red Hat guys, oh no, this company was acquired by IBM. So to IBM, yes. My God, I'm giving the credit to IBM. Okay, so. Anyway, they've done significant work to popularize this pattern among the SRE teams, and to say, hey guys, this is the right way how to manage Kubernetes like an engineers, right? And so, but anyway, this pattern itself goes from Google actually, right? This is the way as Google works and then the core OS guys understood how, probably a few of the first ones understood what's the right way of adopting for Kubernetes reality. But first let me speak about the pattern itself, then I will give you example of the Kubernetes, and then we go into some more like specifics. Yeah, and that's it. One thing which is important, and it does not say explicitly, but you must use general purpose programming language. Yes, I know you can write operator with I don't know, with shell script, with Microsoft PowerShell, with the Puppet. Yes, you can. Just because if you can, it doesn't mean that this is for majority of your tasks is the right tool. Right? Typically, if you see that this is the shell script is or PowerShell is the best tool to solve this concrete operation, probably you don't need operator. You just need a shell script or PowerShell script, right? So, when we need operators, then I would imply that we need a general help of general purpose programming language, and this is how it works. So I have a service, and in my case that will be Jenkins, but this can be any service, which is somewhere in the Kubernetes. It's not limited to Kubernetes. Again, this is pattern, right? And I wrote number of operators actually not for Kubernetes as well. Works just fine. So then I have the operator which talks to the let's say storage. That can be file, that can be database, that can be I don't know, Redis cache, that can be anything, right? Any place where he can store some state, right? And what's here written? He's written some information about what is desired state of my service. When the new change is coming, and this can be human action, or the change may be appear by the cluster events by itself, then the state is changed. What's happening? Operator reacts on this change because it has this something that we call reconciliation loop. He periodically checks the state. Oh, there is a new state. Okay, let me check. What's the state of my service that I'm responsible to? Oh, they are different. Okay, I must converge this this service to the state that I see in my storage, right? And he will do this operation, and he will apply the operation. Right? This is very primitive way, but how all operators work. No magic. Right? But now let's see how does it works from the Kubernetes perspective. I have a pod and I have another pod, right? Sometimes, and for my example with the Jenkins, you might want to pod and the operator and container coexist in the same pod, but at the same time you will have a lot of limitations because they will share not only pod context, which sometimes you want to do, like myself, but they will also share this replica set. So if somebody wants to scale the operator, they will end up with the two operators because they want to scale the service. Right? In general, I would prefer to split them, like to be able to scale my container with my application independently from my operator. Right? Because it's sometimes not a good idea if two replicas of the operator will try to do the same change. Yeah, and so, but sometimes, and there are some reasons, and for Jenkins there were important reasons for me actually to put them inside of the same container. Right? Okay, and then the configuration or this what he will put inside of this database or this bucket or this state, we call in the Kubernetes as the custom resources. Again, the operator is not limited to the custom resources. However, the custom resources has been specifically created for operators. But sometimes you can. But my first operators were just dealing with the config maps, just fine. Right? The custom resource is the extension to the Kubernetes API that can give you a new resources that never existed before. And they will do this, that will be a complete extension to the API. So basically you can access with the HTTP requests and get pretty much resources that are custom to you in the similar way as you get all the services, pods, and precedent volumes, and so on and so on. Right? And what's important for Jenkins, I don't know if you know Jenkins, but there is a pipeline, probably the pipeline definition. I just want to define my Jenkins pipeline and get it. Credentials like secrets and so on, passwords, I might want to inject inside of my Jenkins well, that's the right way of doing things in Jenkins, right? There is shared libraries, and there are a lot of stuff that I can operate with inside of my Jenkins, right? And all these custom resources I will define as something that we call CRD, which is custom resource definition, right? I will just call it CRD. In a minute, I will stop in more detailed way what is the CRD, how does it relate to the custom resource, and so on. But so far, let's stay with this, right? Then, when there is when the new pipeline definition, new pipeline resource, or Jenkins credentials resource, or anything else appeared in the database that operators continuously watching, then it will react on. Then the new event will be generated, and there are typically event resource added, updated, or deleted. Right? And then operator will take a look at this event, and then it will see what it has to do. In my case, it will use remove Jenkins API and go, and this is why I need actually a shared pod, because I don't want to expose the remove Jenkins API to anybody. It's the way as my operator operates with the Jenkins actually sends a fully functional Groovy script there for execution as the post request. By some reasons, I don't want to expose this functionality to the internet. Right. So, and let's take a look what's inside of the operator. And before we will do this, I want to switch to a little bit to the console, just to give you some feeling. How does it look like? And then I will continue with this nice slides. Okay. So, okay, let's do this. Can you see my nice console? Right. Okay. I like consoles. So I have consoles here, and I have my applications here in the GitHub. This is my GitHub account. It's actually Kranga. This is DevClub. Well, it's publicly available, but well, don't criticize, please. This is JavaScript. Don't criticize my skills in JavaScript. Please don't. I have Jenkins here. Jenkins looks approximately like this. I created one test pipeline just to be sure that it is, just a few minutes before this talk. To be sure that it works. But what I'm gonna do is actually on the right side I have a log. This is my Jenkins operator. It's here. It's deployed as a pod, and on the left side I have a console with this. Good. So I have something that is get CRD, and you will see that I already have a few of the custom resource definitions. And what's my right now, which is important, is pipelines. Well, let's take a look. I can write just normal Kubernetes command, and then I see what I have here. Come on. Yes, I have one Jenkins pipeline, which corresponds to this. Wow. Right? What? How does it look, basically? I have a pipeline file which says something that probably not makes sense for everyone, but it makes total sense for Jenkins user. Right? If you're familiar with the Jenkins, you probably know that there is a Jenkins file. This is the Groovy script where the pipeline is created. And I say in this definition that, by the way, you will find the pipeline in this Jenkins file, which is checked in inside of the Git repo, GitHub repo, that I show it to you. Then to access, to be able to do something with this Git repo, you must use these credentials. Then you will actually look at the master branch. Everything else is more or less technical information because what I do, I have my S3 bucket, and because it's a JavaScript application, I will use my Jenkins to compile the code, and then I will put it inside of the S3. Right? And this is the place where I want to put my S3 bucket, my nice applications, right? Well, and there are a couple of more technical information, like what's the IAM role for authentication, authorization, and so on, right? But it's not as interesting. But for me, what is interesting is I have a name here. I would say pipeline will be called I love Kubernetes. No, let's make it even better. I love DevClub. Okay, good. So then I just do apply and set my pipeline and see what's happening. So what is here? Here are some custom resource definitions, and the definition just describes what will be inside. What's the syntax of this pipeline YAML? What should be inside? What should not be inside? And it describes some other information, like should it be namespaced or cluster global resource and so on. What my operator is doing, it is listening to the Kubernetes Watch API. Basically, this is gRPC, and it listens for the resource, custom resource definition called pipeline, Jenkins pipeline. And when there will be a new event, this event will be pushed gRPC. Will be pushed inside to my operator, and operator must react. I hope so. So I run it, and then what I see, you see, operator immediately reacted, and actually is provisioned. Yeah, just executed. This is a Groovy script actually. Yeah, lot of stuff. Yeah, and what I see, let me put the refresh, and what I see, hey, and the pipeline is actually running here, and I see that it's actually started. The build is started. Yeah. Well, this build will take some time because it will do this, utilize this Kubernetes capabilities. It will dynamically create pods and delegate some builds. But for example, if I don't want to do this, and I can just say key Kubernetes delete this. By the way, if I list my pipelines that I have, you see I have 2 pipelines now, right? And by default there is no Kubernetes get kubectl get pipeline in Kubernetes. This is why what I deployed together with my CRD, right? And here I have 2 pipelines, but let me kill one. I will kill this. That's what I created. This key delete pipeline. Bye bye. Yeah. Operator immediately reacted and actually converged Jenkins. And basically, yes, what we can see, yeah, the build is stopping, and then actually the pipeline is deleted. Right. Well, this is how it worked. There are a few things. Which is happening, and I would say that the scenario for the operators are more or less the same always and always. So there is a custom resource definition. Typically, for 80%, 99% of the operators, there will be a custom resource definitions, because that's the most native way for operator to operate. However, sometimes you can stick with the existing application. Just you don't need configuration. You just need to watch for the pod if it's still running operational, right? If your Postgres database is actually still alive. Right, if the cache is good and so on and so on, the persistent volumes are enough and so on. Yeah, anyway, so then operator, when it's up, it connects to the Kubernetes API server and starts to listen this CRD. And then when the change is coming, operator executes a function. He performs the event, and I would say, I would rephrase myself, this event is coming into the reconciliation loop, and then as a result of this reconciliation loop, the operator executes the function that will converge the service to the state that it is described in this event in the reconciliation loop. So this is how the custom resource definition looks like. If you cannot read it, I'll post these slides. Don't worry. I highlighted most important things. What I have the definition called custom resource definition. Then I say that I have a new thing called pipeline. I say that this belongs to this organization, and this new resource will be namespaced. Then I declare this pipeline in the plural, in the singular vocabulary. This is for kubectl, so I could write it nicely. And I can do some short names like pipes, and anything that you like. And you can also use validation API. It's an open API v3 schema, and write this specification validation if you want. I've seen a lot of people not doing this. I like to do this personally because I don't like users to submit whatever they want. Somewhat, I don't know. But what will happen, like in the backend, right? If you don't like run execute command kubectl apply, and you want to do like an engineer, you want to initiate the HTTP request, then you probably will do the post request into this URI that will look approximately like this, and you will send this definition, unfortunately, as the JSON. Yeah, it does not accept YAML. So yeah. The only thing why we have YAMLs because kubectl can convert stuff. Then, whenever you will want to check your custom resource definition, what's inside and so on, you will initiate GET request. That will this part is more or less the same as on the line above, and then you take this. You combine one word from this pipeline, which is singular, and then you combine this group here, and then you can get access to the resource, and you can look at the definition. You can look inside what are the pipelines inside of this what are the pipelines has been created, and so on and so on. But this request will actually give you state of this deployment of CRD. So what I like to do, and I like to put this definition inside of my operator. So when I run my operator, it will go inside of the Kubernetes, initiate this post request if it's needs. So first of all, it does this request to check if there is a custom resource definition that already exists. If it's not, then it will try to create this custom resource definition by itself. It's a very nice and convenient way. You just run the operator in whatever Kubernetes, and then it makes sure that user can use it right away. Right? However, I've seen that many people don't like it, and I understand the reasons. There are primarily security reasons, because you must give to the operator rights to change your custom resources. If you don't trust to this, then you skip. If you trust, then you can go with this approach. If you don't trust the operator, you can always create this custom resource definition manually. And then, after this custom resource definition has been created, you can submit something that is called the custom resource, that will have that will be kind pipeline, right? And the pipeline will be from this group, which we've seen here. All the custom resource definitions are versioned, so you can use different versions, and you can use this iterative approach for your API of your custom resources, which is nice. And then, based on the specification that is written here, well, this specification is super permissive, but you can declare your stuff which will be meaningful in context of your application pipeline. This stuff will be just create a new pipeline inside of the Jenkins folder sample pipeline from the GitHub. Right? That's it. Oh, okay, good. Yeah, good. So, let's be more specific. So, this is how a typical operator looks like. So it has primary class called controller. This is primary thing that is talking to the API server of Kubernetes. And the first thing that it wants to do is actually it goes, here is a request that looks approximately like this for Jenkins pipelines, in this case, and it initiates this watch through, which will create this HTTP to communication, right? And then it will start to listen for all events that are happening here. So basically, it initiates this gRPC event, and then what is happening? Then what we know that behind the API server there is etcd, which is key value store. But this is where everything in Kubernetes is stored, and including these custom resources. And the reason why we can do this watch API, because etcd is also gRPC. Right? In fact, what API server will do, it will just proxy this watch thing to the etcd server. And then when the user will put their new custom resource definition, then in the form of event, there will be sent back a push notification with the event, which will be added, updated, or deleted. Then there will be some little bit technical information written what exactly what CRD has been stored, which version, and so on, and the payload of the resource that has been submitted, right? Then, and this is what becomes trickier. The controller must have a queue, and it will forward this request, this event into the queue. And the queue will send back this resource to the controller itself back. And in a minute I will explain why it must be so complicated. Because we want to start the reconciliation loop, and we want to start it like that. Basically, the new resource is coming, and with the instruction, oh, the new pipeline has been created. Do something with it. Then the operator does action, and then it must see what's the result of this action. Was it successful? Was it not successful? Is the API that of my service that I'm operating with, is it synchronous, or most likely it is asynchronous? Because when I submit my pipeline creation request, I just get to one response like come again later. To see was it actually like was it successful operation or not? Come later. I don't know. I'm a asynchronous guy, right? Then the operator must decide what it should do. If the action has been successful and completed, it will remove event out of reconciliation loop. If it decides that, oh no, it must revisit this later, it will put inside of the loop again with the metadata information like check this event in 2 minutes, or try again 5 times, right? And this is especially handy if your action has not been successful, if there was an error. Right? And because everything is happening automatically, then the operator must perform the decisions what should happen in this case, right? This means that the same message, the same event will come again several times in this queue. Most important things, whenever you put the queue for the Kubernetes, please put rate limiter on top of that. If you don't, then it will a single event inside of this queue that cannot exit by some reasons, which is stuck, can crash Kubernetes API server because it will initiate a lot of requests, several thousand requests per second to the API server, because this action will most likely will initiate its own request to the server. And then basically, yes, it will go down. Do the rate limit, please. Please. And yeah, that was my first experience with this when I wrote my first operator. Yeah, the reconciliation loop. This is more or less repetition of what I have told. There are 4 typical exits out of the reconciliation loop. Was the event successful? If the event has been successful and completed, I can exit it. If the event has been successful, but I must recheck it later, I must put the same event back into the reconciliation loop with the message that come later, when or how many times should I check, right? And then the same logic comes if my convergence action has not been successful. Right? Sometimes I say, oh, it's not successful, I give up. Or I must say that, oh, I must try it again in 5 minutes. Probably this pod is not up and running. Yeah. Anyway, if you care, here's the thing. Sometimes, after you perform an action, you need to collect the results back. Sometimes you don't, and I prefer not to collect the results, because my definitions, which has been submitted until it's inside of my Kubernetes, that's exactly the state that I want my service to be. Right? And if you want to look on the state, just look inside every definition, and you will see what exactly the state of my service that I'm responsible to. But sometimes you do need some feedback to the user. Right? And especially if you run some operations behind that. What you can check, there is custom resources, has sub-resources, and most likely there is a first-class sub-resource called status. And it's actually a key-value pair of your format. You decide where you can put sequence of events or how your state has been evolved during the executions. And that's especially good when you have a reconciliation loop. You need to visit several times this service to converge correctly or incorrectly, and then you probably will store every visit of your reconciliation. You will store the status for the future. Right? Here I just put this thing. I'm not doing it for my Jenkins operator. I just put it for your information. But you can store pretty much everything, right? Build result, build number, everything that you like. But most likely you will put the reconciliation information, right? Because yeah, and very quickly, operator framework. There are actually two operator frameworks that I like. And yeah, I will speak briefly. I will start with the operator framework because it came from the core OS. And what's interesting, and here's a GitHub URL. It has 900 stars, which is I find okay. It's written in Golang. That's the preferred language to write operators. And maturity is very low. It's 0.1. It's actually now today 0.1.1. But don't get distracted because it has 800 commits, which is pretty much okay, right? And what I am interested to look at this. This is machinery. I don't want to write it. I want to generate it, and especially there are a few things that I must be aware about. Like I want to put the right limiters on my queue, otherwise my cluster will be dead, right? So I don't want to write this. So I want a framework to be able to generate all this thing for me, so I can focus on the stuff which is really meaningful for me. And that's what this framework is about. It provides a CLI that can help me to generate the code that I want. And in the nutshell, this is how it looks like. Right? Basically, I want to generate a new operator for my Chuck Norris application. Yeah. And actually, I have the command, this operator SDK. Sometimes this thing has been called operator SDK. Sometimes this thing has been called operators framework. They rename it in the process of writing. Right? But yeah, so I declared this command like operator SDK, write a new operator which is cluster scoped. Then I say, oh please, I want a new custom resource definition. By default, it can talk to the custom. It can generate custom resource definition for me, right? It's not limited. If I'm not needed in custom resources, I will just listen for the pods. I will not run this command. And then after I executed this, I will see that there is a new file here, which will be like Chuck Norris types, go in the library packages, and I will see that there will be Go structures. And this is the mapping between your application and that JSON file. This is why I like to put some JSON, some open API validation, because Go does not really like can go to the parse errors very easily, right? So then what I will do when it's written, I will write this command called operator SDK generate Kubernetes. Then it will look at my definitions, and it will generate, it will update the all other things by itself. Right? And when I'm happy with that, and actually you need to re-execute this command every time when you changed these structures. When I'm happy with that, I'm just run the command like add a new controller. Typically for one custom resource or for one thing that I watch, I should have just one controller. Right, and inside of the controller, I will put. There is an important method called add, which will bind my application manager. This is this is the total container for my application with a concrete controller, and it will. And inside of this method, I can say, "Oh, dear controller, please listen this resource." Right? Or this group of resources. I will put this binding here, and this is, I will use, and this is something. This is plain Kubernetes API. Right. The only thing that I say that, oh, I am listening, I'm watching you from the controller, because that means that with everything what I watch, I will apply a specific lifecycle. When it's done, I write the function that has a little bit more code. I will not stop on everything here, but again, I will share the slides, and I will be happy to answer on every question. But this code is actually, this is the reconcile method, which is important. This is where I make my reconciliation with decisions. What I must do, there is a result structure, reconcile result structure that has been pre-generated, and I must give a feedback to my controller, to my manager, what should it do? Should it, I finished with this event, or it was an error, or I want to put this event back into the queue with some instruction, like 3 more times, right? And here I basically doing this stuff. I make all these 4 decisions that I explained it here for you. I will just make it here in the code. What is not here, in this loop I do not write this status sub-resource information, but here we do. But what is in this slide, whenever I get the event, I get in the payload of the event everything what I need to do, but I do not trust this. I must go to the Kubernetes cluster and fetch actual resource from the Kubernetes cluster, and then I must compare. Okay, this resource I received in the payload. This resource I have in my cluster. I compare it, and then I understand what should I do. And this is the right way how operators should actually operate. Right? And then there might be collisions when there is event happening like modify this resource. I go to the Kubernetes and say I don't see this resource, it's not found. What should I do? This is interesting. This is again interesting question, right? It depends. This kind of logic must be handled here in this reconcile. This is most important method of all your operator. Yeah. When I'm done, there is already pre-generated Docker file for me, for my operator. I can just build my Docker file and push it, and all this stuff, and there are a number of Kubernetes resources like role, service account, and role binding, and so on. It's already has been pre-generated because I run some CLI commands. Right, and operators take care about this. If I don't like it, I can change it, because this is a bootstrap pattern. So whatever I don't like, I just write my own stuff. And I use this CLI at the beginning when I create my operator. I need to bootstrap and use custom resource definition inside of my operator, and then I leave it, and I say the code rewrites pretty much everything typically, but it's a good thing for me to start with, and that makes me super productive. And then when I'm happy, I can test I can deploy to my cluster, and then I can deploy my CRDs. It will even generate some sample custom resources for me to test. Right? Even tests. I did not put test, but it will generate some tests as well. So it's a nice thing. If you, by some reason, don't like this this operator framework, there is a kube builder which is looks approximately the same, similar, very similar. In the code that they generate, they look similar. The biggest difference for me, one, it is maintained by core OS team. This thing is maintained by well, this is officially has been accepted as the Kubernetes incubation project, right?
CSV?
Sorry?
see it there.
Well, it's this SIGS. This is their own incubation repository. Yes, it doesn't mean it will not. It is super mature and super stable. It's but it is just how to say. It is I would say baked by the little bit baked by Google engineers. It has a nicer version. It has 1.0.5, and next version will be 1.9 already. But if you look at the number of commits, it is less commits. So do not be frustrated by the version numbers. It version number means nothing actually. Right? But from the age of the projects, two projects are pretty much the same age. They generate pretty much the same code, the same stuff. They are super close, and just if you don't like one, just pick another. That's it, right? And both of them written in Go. I must say it. There are two more frameworks, but it's not for operators. If by some reasons you do not tolerate Go code or just general purpose programming language, and you still want to write operator-ish something, then you can take Knative, which by the way will force you to install Istio. And then you can in the Knative you can define your. This is like serverless but for Kubernetes. And it can generate the events based on the. It can listen any resource that you want and then generate the event and then trigger some lambda-ish function, right? And if you like this approach, you can write it, but again, this will not be operator. It will be something else, and it will ask you to bring Istio. I'm not saying Istio is bad; it's just big. I must bring this very big thing for my small operator. Right? And for Argo, it's another framework. It's a general purpose workflow engine for Kubernetes. And it requires NATS, message queue, or, well, it can work with a zero queue or RabbitMQ, but NATS has smallest footprint over the second and third. Right, and just I put NATS here, but it can also put some watch triggers and then do the things. And it will trigger the workflows that you can define. And if you're a big fan of SOA architecture, then probably this is your choice. But it will not be operator, and you will bring again a lot of overhead with your stuff. Overhead will be NATS and plus some Argo runtime. Right. So, some takeaways. So, if you want to write operator, just take Go language. That's it. My first operator, and actually Jenkins operator, I wrote in Java. Don't do my mistake. Have you seen the Java memory footprint? Right, you don't want to do this. And when I will not be lazy, I will rewrite it for Go. But yeah, And Java has a nice library. Fabric 8 that can, I based my framework there. It's not nice actually, I lied. It's not nice, it's very bad, and my personal opinion, I hate it. Right? And I can explain with a couple here in the very deep details which exactly code and I hate a lot. Right? So, do not write a generic operator for everything. There will be one operator to operate them all. One application, one operator. One pod, one service to monitor, one operator. There will be a small group of fine-grained operators, because operator is good when it automates one but very specific operation. Then you can write it very efficiently, very fast, deploy and forget. Use frameworks. Before actually I implemented my first operator in Java, I tried to implement it in plain Kubernetes API with all these rate limiters and so on and so on. that was even worse than fabricate. Right? I wrote several thousands of Go code, several thousands of lines of the Go code, which was totally meaningless. Right? Use frameworks, please. Yeah. And there are two nice things that I specifically like in Go, Viper and Cobra, and put your configuration information about your operator there, right? And that's it. Do not try to hard code anything. Just put it in this in Viper and Cobra, and it will be nice. Yeah. And yeah, basically that's it. So thank you very much.
So let's do these questions that you asked them directly in a break time. Thank you, Antons, for your talk.